Well, hello everyone, and welcome to the first in a series of 8 weekly webinars featuring one of IFAI's partnering organizations, North Carolina State University's Wilson College of Textiles. Today's webinar is titled Intro to PPE Production, featuring a Q&A with North Carolina State's Wilson College of Textiles. My name is Aaron Monson. I am the Education and Events Manager here at IFAI, and I'll be helping to host today's session. I'm joined by the IFAI team, Janelle Wells-Berkeley, Megan Furl, and Annie Castle. Co-hosting today's webinar is Melissa Sharp, Associate Director of the Zeiss Textiles Extension at the Wilson College of Textiles. A huge thank you to Melissa for project managing the development and execution of these weekly webinars. And we are equally indebted to our association partners, listed in no particular order: SEAMS, the Association and Voice of the U.S. Sewn Products Industry; ICP, Association Connecting Electronics Industries; and SPISA, the Sewn Products, Equipment, and Suppliers of the Americas. Textile manufacturers have responded to the COVID-19 crisis in unprecedented ways, rapidly retooling production lines to manufacture materials and products for PPE. Many of these companies face challenges from understanding performance requirements and new materials to navigating a challenging maze of testing requirements and use guidelines. So in our first webinar of the series, we'll introduce some basic principles of PPE production and our panel of experts in PPE testing and design, nonwoven and filtration materials, medical textiles from NC State will answer your critical questions, so don't be shy about asking. Today's webinar content is brought to you by a thoroughly experienced group of faculty and researchers with various areas of focus. You can see them up on the presentation slide now. In no particular order, we have Emil Dane-Hartog, Director of Graduate Programs, to ECS Associate Director of TPAC, Stephen Sharp, Director of Engineering and Operations for Sanctuary Systems, Cassandra Kwan, Research Assistant Professor at TPAC, Karen Leonis, Professor Textile and Apparel Technology and Management, Mark Matthews, Research Associate, TPAC, Roger Barker, Director, TPAC, Don Thompson, Associate Director, TPAC, Andre West, Director of Zeiss Textiles Extension, Brian Ormond, Assistant Professor to ECS and TPAC, Will Duncan, the Executive Director of SEAMS, Martin King, Professor to ECS, and Michael McDonald, President of SPISA. We are so pleased to have everyone with us today, and thank you for bearing with us as we are all working remotely, so we hope that you will forgive any technical challenges that may unexpectedly occur. So again, this is a Q&A session, so after a brief presentation, we'll open up to questions. You have the opportunity to submit text questions by typing them into the questions box of your webinar control panel. You may send in your questions at any time during the presentation and we'll address them when we get to the Q&A. And as a reminder, don't be shy since we want your participation. At the end of the webinar, there'll be a link to a Google form where you can submit questions that weren't able to be answered today or might warrant further discussion with a particular member of our panel. So look for that when we're all done. And finally, a PDF version of the slides are available to you in the handouts portion of your webinar toolbar. So with this, I would like to now turn things over to Mark Matthews, who will give us a brief overview and get the conversation started. Mark, I will send over a request to share your screen. Perfect.
All right, good. So I'm going to give a quick overview in terms of the introduction to PPE. This is geared mainly as a high-level introduction to personal protective equipment in general. So if there are things that you already know, that's good. I just wanted to give everybody sort of the same baseline in terms of the different types of things that we're talking about. Just quickly, my background. Let's see. Okay, quickly, my background. I'm a former Marine. I have worked at NC State, gone to NC State, have worked with the government, have worked in the textile clothing industry, primarily in research, development, engineering. Just to give you a background, about 20 years or so within this industry. I work for the Textile Protection and Comfort Center here within the Wilson College of Textiles at NC State. We are an academic center within NC State. We have within our labs the ability to research, test, and evaluate comfort as well as protective performance of textiles, garments, and full ensemble systems, to include a lot of the equipment that is included in sort of the broad range of PPE. So again, I don't want to make this super extensive or long, but I want to be able to introduce PPE to everybody and then discuss some of the aspects that really makes PPE different and unique within the world of textile-based products. So PPE, by technical definition, equipment or clothing worn to minimize exposure to a various range of hazards. The hazards can usually cause serious injury or illness. So examples of types of PPE, I'm sure everybody's familiar: gloves, safety glasses, shoes, earplugs, hard hats. A lot of the things that everybody's more familiar with probably nowadays are things along the lines of respirators, hospital gowns, things along those lines. So a quick background to the overall market of protective clothing. Within the global market in 2019, the market is about 8.8 billion US dollars. It's projected to reach 11.9 billion by 2024 at about a 6.3% growth rate. The smart PPE market, which is essentially integration of smart technologies into protective clothing, is expected to grow even at a faster rate at 16% between 2019 and 23. Currently, this data is from the fall, so it might be slightly off, but North America is the largest market. Obviously, there have been some recent changes within the beginning of this year, so that could also impact the differences, but typically thermal and chemical protective clothing are the two largest and fastest growing segments. So the various types of hazards that we may talk about. This is a very extensive list. This is probably just a small number of the type of hazards that PPE is used for. You have thermal hazards, chemical, that includes liquids, vapors, aerosols, radiological, biological, a lot of the one that's on everybody's mind today. That also includes particulates, aerosols. We have environmental hazards. This could be exposure to the elements, the terrain, the weather, physical, mechanical, electrical, explosive. And then there's a series of sort of category that I put down here is long-term or unknown. For example, within the fire service right now, there's more recently, there's been higher cancer rates within the fire service firefighters. So that is primarily due to the toxicants that are within the smoke that come off of fires, vehicles, things like that, and that's leading to cancer. So there are undoubtedly some longer term or unknown hazards that we're not necessarily protecting from right now, but that are out there. The other way we can talk about PPE, in addition to the hazards that the PPE is protecting from, is the end users and the applications that the PPE is used. My background is from the military, so you can see the various types of PPE in this photo here of the howitzer firing. You can see the various items that those Marines are wearing. There's healthcare and medical. Obviously, everybody's, again, the current situation, masks, eye protection, gloves, isolation gowns, all of those things are included in there, and those are typically healthcare workers EMS, firefighters, people that are responding to potentially infected patients, things along those lines. Firefighters, law enforcement, these are, again, other first responders. These are more examples of the types of end users. The oil and gas industry has been another sort of influx into the U.S. in recent years. These are jobs that, again, need some sort of protection, whether it's from the heat or the oil, gasoline, those kind of things. There's also other applications, construction, manufacturing, mining, warehouse logistics. It doesn't have to always be a garment that we're talking about for PPE. It could be as simple as eye protection or gloves. A lot of times in, say, auto manufacturing, it's cut protective gloves for the workers there. And those are all considered PPE. And then there's other things that are more specific or specialty, food processing and food processing plants. You'll find a lot of cut protective gloves. You have to have protective gowns, all of these types of things, booties, things to cover the body while you're operating that job. Do it yourself is another category, albeit smaller. It is still an area or end user that may require some PPE. And then within the current time, we're finding there's a lot of new users, which is generally the general public. Obviously, with all of the guidance coming out in the last couple of months, wearing masks, everybody's being familiar with sort of PPE on a personal level. Typically, that hasn't been the case. However, it will most likely move in that direction. So some other categories that we can look at PPE by, you can look at it by durability, wear conditions, whether it's disposable, reusable. Again, I mentioned hazard and end user earlier, but there's also design aspects to PPE, single piece, multi-piece. It could be worn over your daily wear uniform. It could be worn as an undergarment. You could wear it just as a apron or a helmet on top to protect your head. And then there's a lot of different standards. Most PPE items that you will purchase or produce will have some sort of standard specification, purchase order requirement that garment or that material or that end product will need to meet in order to be considered a certified PPE item for whatever the end use is. So the examples there, NFPA, EN, ISO, ASTM, mil specs, all of those are different standards or specifications that will lay out how each of these systems needs to perform. So that leads me to sort of the main idea. How is PPE different than most other textile-based products? Well, first of all, the key that I like to point to is human safety is involved. There can be severe consequences if the garment that you're producing or making fails. So that adds a little bit of an extra safety component to producing and creating these types of systems. In a lot of cases, the user or the consumer is not always the purchaser. So within the areas that PPE is typically used, say it may be within an industrial plant, or it may be within a volunteer fire department, or it may be a police station. Typically those users aren't necessarily in charge of buying their own equipment or gear. In some cases they do, but there's a lot of cases where these systems are purchased and then given to them. So that can create some unique issues when you're looking at the performance, and especially related to comfort, fit, size, things like that with PPE. And another unique thing here related to PPE is typically, for the most part, the PPE systems are used in extreme environments. And they're not only used in the extreme environments when they're first come out of the box, but they typically have to be used over a period of time in that same environment, and it needs to be as good on that 50th day as it does that first day. So that brings into a very high importance of durability, and not only durability in the sense that the garment's not going to fall apart after a period of time, but it also brings in durability of that protective element. So if you have chemical protection, you're wearing a chemical suit, it needs to be good for 50 days after 6 launderings in order for the user to feel comfortable wearing that, and in order for it not to fail, it needs to have that same protection on day 50 as day 1. Another key difference is oftentimes protective clothing, protective equipment has complex architectures. So there are many pieces, parts, layers, components that are worn with it. So for example, in this picture here, you see all of those textile-based products that those Marines are carrying. Those all have to function as one system, and the protective clothing piece of that, whether it's the ballistic vest or the military uniform, are one small piece in all of the other architecture of the system protection. So typically it's not just worn as a single garment. There are things that go on the outside or underneath, or have to interface or have to integrate with. So that creates requirements related to protective clothing and equipment that you have to have compatibility with a lot of different items. So it's not just put it on and wear it out into the street. You have to consider all of the additional scenarios that these systems will be worn in the actual user cases. There's often a lot of competing variables with protective clothing. So the most often, I guess the most often competing variables we talk about for protective equipment and clothing is protection versus comfort. They're often, it's very difficult to get one and also get the other at the same level. So for example, if I have a firefighter turnout suit that has to protect against a certain thermal flux over a period of time, I could make a suit that has so many layers and is so thick that there's no way that that person is going to get burned. However, the person that is wearing it may not be able to use it because of that thickness. So there's a balance there. There's a user need aspect, a comfort, a functionality that needs to also factor into the equation when you have protective equipment and clothing. And then finally, the last one I have on here is the materials that are typically used are high performance. They're often require specific and technical expertise to produce. They can be expensive. So, you know, this example you see here, this is a multi-layered system. It's not only a textile material, there's membrane layers, there's cushioning layers, there's fabric layers. So all of these components need to be put together in a way that typically provides that protection or meets that requirement that you're looking to meet. So with that, finally, I just wanted to quickly pose the question for you to think about, and maybe we can ask the panelists as we go through. How do you think the PPE market is going to change due to the COVID-19 pandemic? Quickly, I can already tell you that I can see within the areas that I work in that there is a specific need to move from disposable items into reusable items. I'm sure everybody's familiar with the shortages in a lot of the different PPE. Typically, the shortages of those are due to disposable items. So they typically can't be decontaminated. You use them single use, throw it away. Well, now people are having to figure out, can we decontaminate them? Can we reuse them? So you may start to see some of the market moving towards reusable systems in lieu of having to have disposable items. And also there's going to be some interesting, at least from my perspective, now that PPE is much more common within the general public, it will introduce some interesting requirements into the PPE development process, which typically may not have been there. So that's sort of a quick overview. And with that, I will set it to Aaron and go from there. Thanks for your time.
Thank you, Mark. I'm just going to get our PowerPoint presentation back up here so you can see all of our wonderful panelists today. We'll get going with some of the questions. I've got a handful already. So just a gentle reminder to panelists, make sure that when you're ready to answer a question that you are not muted. So I'll just go ahead and start with the questions. I have one question that asks, can you explain what N95 means for masks and why those are in such short supply? And it looks like this might be a question best answered by perhaps Emil or Steve.
Steve, you might probably follow where I leave. The N95 is pretty much a designation of respiratory protection. The 95 stands for the 95% of particles that are being filtrated out during a filtration test. That is specifically on small size particles in, I think NIOSH tested at 0.3 micron, so 0.3 micrometer that is. There are also N95, P95, and P99s that pretty much all tells you how much needs to be filtrated out. The N95 masks are not just tested for filtration of the material, but also for the fit of the masks on the face. The interesting thing about the whole discussion about masks is that the N95 masks are not tested, evaluated, and certified by the FDA, but they're certified by NIOSH NPPTL lab in Pittsburgh. And they do these tests and according to the federal guideline that is out there. Most N95s, actually currently all N95s exist on non-woven materials, specialized and engineered so that they perform the filtration of these small particles. Specifically, the 0.3 to 0.5 micron particles are very hard to filter, and that's why these sizes are targeted specifically. And I think I'll leave it to Steve to explain more on the materials and why there's so much short supply currently.
Yeah, thanks, Emil. The shortage basically comes from the situation where a lot of the masks were, of course, made overseas. I know 3M was making a lot here for the N95 type materials. And of course, we had our general medical suppliers that were making them as well. But, when you build equipment to make these kind of things, you only build equipment to meet the current market demand. And of course, you don't spend millions of dollars on equipment and if you don't need it. So when the demand spiked rapidly, you're talking about reacting with equipment that can take 6 months to 18 months to install. A lot of folks ran right out and purchased the mask machines, and the only people that actually made the machines that made the masks themselves were actually in China for the most part. And so they bought a lot of these machines, but then they also had to realize that the feedstocks were also severely stressed. And that feedstock, the main one was melt blown, which creates the 0.3 micron, 95% filtration level, was already in short supply. And we knew this back in February. I went to a filter show in February back in that they put on back up in Chicago, and everybody was already sold out by the end of the show, and that was in the beginning of February. So we already knew it was coming. The filter materials are already sold out. Lots of folks bought the face mask machines, had no feedstock to feed them with, and there was a big scramble for melt blown. Now, the machines that make the melt blown are the people that make those machines are working very hard to put out a lot of capacity right now. So that should correct itself hopefully soon. We're looking at doing the same. The spun bond has a lot of capacity, and we're thinking that the spun bond, which is the outer layers that you actually see in most N95 masks or surgical masks, that component already had plenty of capacity, and we're thinking with a capacity loss from other sectors for that stuff and for the feedstock of polypropylene will actually help feed the need for the PPE. So kind of a long-winded thing there, but when you think about these things, you got to think about the full supply chain, and the big bottleneck was the melt blown manufacturing machinery.
If I may add to that, I think besides the technical aspects, why nonwovens are particularly so good, because they have these small microfibers that filter out particularly well, and there are some technical additions to that as well. But another reason why the nonwovens are used for these N95 masks is cost, because they're disposable items. The nonwoven production is a cheap sort of production for these high-tech materials. And I think for industry trying to get into this market, trying to doing anything else than nonwovens, that cost of production and cost of face masks, when this pandemic is over, the economics of it always had hospitals buy at the lowest price possible. So for the long term, that is something to keep in the back of your minds, I would think.
Great. Well, thank you for those answers. Questions are coming in at a rapid fire pace, which is awesome. I'm really excited to see all of this interest and engagement. So I'll more or less start from the top here and work our way down through all the questions that we can with the time we have. So we have a question from Liz. Hi, Liz. Thanks for being here today. Let's see. Her question is, how much PPE covers multiple standards, such as one piece of PPE covering INO and MIL spec? ? And I apologize for not knowing the abbreviations as well as you all do. But whoever on the panel wants to answer that one, go ahead and chime in. Mark, perhaps this is a question for you related to standard.
Yep. So typically you have a garment and you get it certified to a particular standard. As a producer, in order to say that it meets that standard, an independent test body usually needs to test that and certify that it meets each of those requirements within the standard. So you may have a garment that can meet multiple standards, but it will still have to be certified by each certifying body to meet each specific standard. Mil specs are slightly different because the mil specs are typically put out by the DoD, and they usually come along with a purchase description, which has all of those specifications in there. So when you bid to that for the government, then you essentially provide them with the data, or they do independent testing within their labs to indicate that it meets those mil specs.
Great, thank you, Mark. Well, it looks like here's another question on testing and certification. This is from Angela. Hi, Angela. Can we get more information on the testing and certification process of PPE? How long does this typically take, and how long are current backlog times?
Yeah, I can probably start trying to give an answer. This is Emil here. PPE is such a big generic term that is hard to answer this question. So if we would, for example, go For the N95 masks, you would need to reach out to NIRS and PPTL labs to see what their backlog currently is. I think they are all under pressure to do it as soon as they can. If it's other types of protective equipment, for example, medical and surgical masks, surgical gowns, those types of products, if they should meet the FDA requirements for medical products, it is up to the standardized test institute, as Mark was referring to, if it's FDA here in the US, to determine how fast they would be working. So there's no guideline there. If depending on the complexity of the product and how many steps are needed for the certification, it can be pretty quick, up to a month-long process if biocompatibility tests would be needed, or other types of expensive and extensive testing would be needed. There's no just one quick answer for that.
Yeah, and Emil, I would follow on and say, so typically the process is you have a product that you are trying to meet a specific standard. There are places like the SEI, UL. SEI is the Safety Equipment Institute, I believe, and UL Underwriters Laboratories that act as independent third-party sort of certifiers. Typically, those are your first stops for to talk to those labs about the specific certification that you're looking for your product. You go to them, you provide them with items, they do all of the testing, ensure everything meets all of those requirements within the specific standard that you're looking for, and then they would provide you with that certificate. Then you could, at that point, claim that you meet the standard with each of those garments. I'm familiar with SEI and UL. There may be others. Certainly, there are in Europe and other places, but those are the two main ones I know related to NFPA type requirements.
Okay, thanks for your answers there. I'm going to move on to the next question, and this one I am going to direct at Andre. The question is, would hemp be a good fit for PPE as a new material?
Hemp is, no, not for the COVID-19 virus. I wouldn't think it's, hemp has some antibacterial qualities, but I think this is a very aggressive virus we're talking about. So I wouldn't recommend any natural products. The only products, like Emil said earlier, you have to work with the non-woven material that is not letting the pores through. So, and you can't get that fine with a hemp product that I understand. Now this may be good for other sources, maybe a common cold or something like that. But I think if you're looking to do COVID-19 protection right now, and if I can just go off track a little bit, and there's so much out there regarding masks and what's out there. Most of the masks, and I'm sure Emil and other people on this call will back me up, are pretty useless, right? So this is a very aggressive, and I know people have said where something's better than nothing, but you have to be careful about if it is or not, because you would limit your social distancing if you have a mask on. That shouldn't happen. You should still keep the social distance no matter what. And so I would suggest that most masks need to have some sort of non-woven filter, whether that is part of the product or inside the product, to be safe from the COVID-19.
Great, thank you, Andre. I'm going to move on to the next question here. This question is from Melissa, and it could possibly be directed to Emil. The question is, it appears to be the Wild West in PPE. I've seen counterfeit documentation accompanying level 4 gowns. What is being done to address this?
Ooh, so I'm afraid I've heard that term, the Wild West, out there from various sources in Europe as well as here in the US. People who are aware of what hospitals specifically would need to buy are trying to educate a lot of people, but I have to admit that a lot of buyers, people who do procurement for smaller and larger hospitals, do not always seem to be entirely aware of what they should be buying. And the level of fake certificates out there is such that it's sometimes hard to track them down. There's multiple discussions. If you look, for example, in LinkedIn and social media around the Chinese export mark versus the CE mark and how you can distinguish them, and they're very close together. So it's not easy, and I would have to say, when in doubt, try to find someone who has expertise and can help you sort it out. But especially when and the only thing I can say, I think there's relatively few companies who are deliberately trying to make and create fake certificates. There's a lot of people who might not necessarily be educated in what is needed, but deliberately faking a certificate that is kind of next to borderline criminal, I would think, and that is relatively rare, I think, especially from producers here in the US. But there's not a lot that is actively being done against that, I have to say. So try to find resources, try to educate people in hospitals, and a lot of people are trying to do that. But it is hard against everything that is being put out there and pushed out there.
But I think I would add one thing that to Emil is that if you buy something from overseas and it wasn't imported by somebody else, you are now, from liability point of view, you are the manufacturer in the United States. So if I import masks and resell them to you, as the importer, from a liability point of view, I'm the manufacturer, and I have to say this is what this is. If you buy something directly from overseas, you're going to have little recourse on liability and restitution if those PPE products do not meet spec.
Yep. Thank you, Steve.
Well, excellent. Next question is about the U.S. textile supply chain from Brian. Hey, Brian. I am convinced that the U.S. textile supply chain has the ability to provide more PPE products than is needed in the U.S., but the buyers are not prepared to pay U.S. price points. How do you see this problem getting resolved? And that is not directed towards anyone in particular, so whichever panelist feels the need to chime in, go for it.
I guess nobody dares to chime in on this one.
I can pick someone at random. Go for it, Emil.
Yeah, it's and I tried to hint at that earlier in terms of the market being driven by low cost. Hospitals have been buying by low cost, trying to minimize their stockpiles. So I fully agree with the notion that the US should have sufficient production capacity to address all PPE needs, but it is very much a low cost, and I'm not an economist, so I don't know the appropriate terms, but it's low cost consumables that people are looking for. And what Mark was saying earlier in his introduction, I really hope, and I'm moderately optimistic person generally. I hope this will open up people's eyes to see that it's important to have things that are sustainable, durable, reusable. But in the end, it comes down to who is going to be the buyers when this pandemic ends and people try to get back to normal. And I don't think anybody has addressed that fundamental issue of this supply chain problem on PPE yet.
This is
Okay.
Will Duncan.
Go ahead, Will.
If I could add, yeah, it's Will Duncan with Seams. Emil, I agree with you. If once things start settling down, if the buyers, not the users, but the buyers are allowed to go back to just chasing the cheapest, sourcing from the cheapest place they can get it, we're going to be right back where we were. I think it's incumbent on the entire U.S. population, in particular the ultimate users of this, to not allow that to happen. to have a voice and to make sure that some type of something is put in place to ensure that the U.S. does retain these capabilities, whether it's at the full amount, necessary for a pandemic or not. It certainly needs to have some capabilities. We all know this. None of us want to go through this again, or even in the fall go through this again. So I think that, from my perspective with seams, we've watched an entire industry, textile and cut and sew industry, come together and be the primary producers of PPE during this time of need. Now, granted, the demand is much higher than there is capacity, but our industry is the one that's been doing this, and most of these companies showed the ability to pivot their production in a matter of sometimes days, and certainly within a week or short weeks, both from the cut and sew standpoint, as well as on the textile side, where many of our members have been able to transition their existing equipment over to producing appropriate materials to support the PPEs. So the industry can handle this and is, and hopefully, and I think we can bring our prices down. A lot of the folks who are not using, technologies in their processes will probably have a difficult time competing, but those who are, embracing automation and looking at those, I think we can bring our costs down to where we can satisfy those needs. We're certainly not going to be cheap Asia labor rates, but I think we can bring something down that the ultimate consumers can or would be willing to pay for. So hopefully we see that transpire.
Great. Thank you very much for those answers. The next question I am going to direct to Cassandra. And this question is, the requirements of seams being the same level as the fabric works for non-woven that is ultrasonically welded, but what are options for traditionally sewn gowns to address this barrier area?
Can you hear me?
Sandra?
Sorry,
Yep.
I was on mute.
You're all good. All good.
Well, yes, traditionally you are seeing the welded seams, and for the type of non-woven materials that we've been talking about, especially in protective clothing, that's usually sort of the standard. When we look at seams, again, it depends on the material, and then also depending on the type of PPE that you're looking at. But really it comes down to the materials really in terms of their performance. And so when you're looking at composite materials that have potentially absorptive or adsorptive qualities or performance, you can look more at and Mark, you may be able to fill in this a little bit too, just from your military expertise. But a lot of seams that we're looking at are more of sort of just a straight stitch. But again, it's a very difficult question to answer, just because you're looking at this from the what the use of the garment is. And so for masks, a lot of what we're seeing right now are people just sewing it on their sewing machine, which is straight seams, which for the purpose of just covering your face would be okay, which would be fine. But when we're looking at the actual use of it in the medical field, unfortunately, we are having to look at a tighter seal around the face, and a lot of that without any bunching or any sort of air gap. So you really are looking at more of the welded type of close fitting seams. And Mark, if you have any additional points to feel free to chime in. I hope that answers that question.
Great, thank you. Mark, did you want to add anything to that, or I can move on to the next question?
I think you could move on to the next question. I didn't completely hear the entire question, so I'm sorry.
Okay, fair enough. Okay, the next question I'm going to direct towards Brian. What regulatory and testing bodies have jurisdiction over surgical and procedure masks?
So if I believe the specific to surgical masks, you're not necessarily looking at NIOSH. I was actually doing a little bit of research on this as this topic kind of came up, and looking at surgical masks themselves are really by the FDA, and there's a wide range of particulate filtration levels that could be allowed. And I think if you can go to, I believe it's NIOSH's website where they actually talk about the differences. There's a pretty good reference site. It talks about, like I said, the differences between N95s and surgical masks. And if I remember correctly, the surgical mask, you just basically have to show performance similar to something that is currently on the market. And so they range between, let's say, if the N95 is 95% or better filtration, surgical mask materials can be anywhere from 20 to say 80%. There's a wide range that's available there because they're different materials, different manufacturers, different uses, I guess. We've done some testing recently, some testing that we developed in the lab just to be able to try to compare, and you can see a vast difference in the products that are currently out there, just doing a very simple particle filtration test. And so right now that's kind of where you're going with FDA regulations. That's, as far as I can tell, that's where it is. And then the other types of true respirators instead of face masks, the N95 and higher, those are ones that are looked at through NIOSH certification. One thing I did want to add from one of the previous discussions about the N95, though the letter at the front does mean something. The N means it's not resistant to oil. You also have other ones that are a P and an R, meaning they are either resistant, moderately resistant, or heavily resistant. So just to kind of give you a little bit more information on what that number as well as the letter corresponds to.
Yeah.
Excellent, thank you, Brian. Emil, did you have a follow-up to that?
No, I think it was sufficiently clear. So the surgical mask, surgical gowns, medical masks is all FDA approved, falls under FDA clearance and FDA rules, whereas anything that is true respiratory protection, which surgical masks and medical masks are not, that all falls under NIOSH and the NIOSH certifications as respirators. That is protecting the respiration, whereas surgical masks and medical masks are not protecting the respiratory system of the wearer, but they are protecting the patients classically. That's why they fall under the FDA.
Great, very good, thank you. The next question I'm going to direct towards Steve. With the amount of mask machine investment currently being brought into the US, do you foresee a situation of oversupply in the next 12 to 18 months?
That's a really great question, and it's something we ask ourselves all the time. I've spoken to some melt-blown manufacturers, and they're bringing in dozens of melt-blown machines, and there's a lot of people out there with mask machines. I think the answer to that depends on how the general public reacts in the long term. If the general public is inclined to, especially those folks that live in the big cities that are really more conscious about these things, are inclined to wear a mask more often like they do in Asia, I don't think we will overcorrect. On the other hand, if we go back to the way we were, it surely will be an overcorrection.
Okay, thank you. Now I have a question for Mark. What makes a 65-35 polycotton blend level 1 certified for medical use? And how could someone get their fabric recognized as being certified for medical PPE use?
So that is a very detailed question. I don't know the answer off the top of my head. 6535 polycotton blend, level 1 certified. So I would have to do some research on that. I don't know if anybody else on the panel knows that those exact standards off the top of their head, but if you want to get with me after, I can certainly help you work through that and find out the details on that.
Sure, Mark, and we'll obviously be sending the list of questions to all of the panelists afterwards, so we'll make sure that you have the opportunity to follow up. Okay, we have time for a couple more questions. And again, thank you everyone for your incredible enthusiasm. I'm looking at a list of dozens of questions, and I'm really sad that we won't be able to get to them, but we'll make sure that we share these with the panelists and that your questions get addressed. So I'm going to bring a question back to Emil, and this question is, what is the difference between isolation and surgical gowns? What level and type of gowns need to be FDA registered? FDA information is not clear and sometimes contradicting.
Yes, it is. So it's medical versus isolation gowns, right? So basic medical gowns, and I think it also refers to the previous question. There are in those medical products, there are 4 levels, whereas the minimum, I think level 1, level 2 are pretty much just splash and liquid, not just water, but bodily fluid, we should say, resistant. Whereas if you go up the levels, it becomes more of a protective garment. The isolation garments, if I'm correct, are level 4, and those are having higher levels of not only splash resistancy, but also there is a test with artificial blood as well as viral penetration. There are liquid penetration tests under pressure that it should withstand. It also has, I think, some level of particle filtration as well, to make sure that a wearer in an isolation gown, isolation ward, is indeed protected against the environment. Be mindful that the basic levels 1 and 2 of medical and surgical gowns and masks are pretty much just to keep the exhaled and splashing bodily fluids during surgery, etc., away from the surgeon, and make sure that the patient doesn't get contaminated. The level 4 really is a high-level protective garment that requires higher level of liquid penetration resistance with artificial blood, as well as viral penetration resistance, flammability, not to forget. Anything that needs to go in surgery and surgical gowns needs to have a minimal flammability requirement. And I think that is pretty much it. FDA has those 4 levels, I think, for gowns as well as some masks as well. Did I forget anything in the question? I think that was pretty much it, right?
Yeah, you got it. That's good. All right, so with the time that we have left, I'm going to throw one more question out here, and this question is for Steve. This question is, non-wovens are the basis of current face masks. What obstacles would you see to the introduction and acceptance of a woven textile face mask, which has inherent antimicrobial agents, is washable and reusable? Steve, did we lose you?
No, here I am. Sorry.
There you go.
I thought it didn't go. So what makes the melt blowns and the spunbonds, the nonwovens work, is what's the random nature of the way the fibers are laid down. Especially with melt blown, you're talking about fibers down to 2 and 3 microns. It's going to be hard, and there's other technologies that are going on here. So we're going to have our next talk, we're going to go in more depth. I'll have some slides on why this works and how this works. Having a woven reusable mask that will, or other type of filtration that will actually do good percentage rates at 0.3 microns, I think is a really tough hill to climb, especially with a good pressure drop. Because remember, when you breathe through these things, you don't want to have to breathe hard through them, or you can't wear them for very long. So you know, I don't see a good option forward with reusables, and but we are working on that. There are some neat technologies coming up, but I don't think they're going to quite meet the N95 threshold. They'll probably be good for a streetwear, folks to wear the street day in and day out, but not for PPE. You know, I wouldn't say it's for PPE. Yeah, tune into the next one where we'll talk more about why the nonwoven is a better option, and why it's difficult to use other materials.
Well, excellent, Steve. Thanks for that answer, and thanks for the nice, easy transition into the next webinar. We're out of time for today. I want to thank everybody for being here today, from our wonderful panelists to an incredibly engaged audience with more questions than we could ever hope to answer in an entire day. Rest assured that all of the questions that you have asked today will be passed on to the panelists and hopefully answered. There is also, as you can see on the next slide, a form here that you can click, a Google form. Click that link and it'll take you to a nice little easy form where you can submit further questions directly to the panelists. You can also access this via the PDF handout that is available to you on the webinar control panel. So once again, thanks so much to everybody today for being here and for the great conversation and the great questions and great answers. Whoops, there we go. As Steve mentioned, the next webinar in our weekly series is called Nonwovens Technology in the Production of PPE. Registration is available on our website now, ifai.com/events. That's next Tuesday, May 19th at noon Central, 1 p.m. Eastern. An email announcing registration with a link will go out tomorrow at about 10 a.m., but you can access that now on our website. All webinars in the series will take place Tuesdays at 12 noon Central through the end of June. Once again, my name is Aaron Monson. I'm the Education and Events Manager here at IFAI. I'll be helping to host all of the sessions throughout the next 8 weeks. We're joined by IFAI team members Janelle Wells-Berkeley, Megan Furl, and Annie Castle. Thank you again to Melissa Sharp, who is co-hosting and co-organizing today's webinar. Melissa is the Associate Director of the Zeiss Textiles Extension at the Wilson College of Textiles. Thank you so much for project management on this webinar series and bringing everyone together. We're equally indebted to our association partners, again in no particular order. SEAMS, the Association and Voice of the U.S. Sewn Products Industry, ICP, Association Connecting Electronics Industries, and SPISA, the Sewn Products Equipment and Suppliers of the Americas. For more information about IFAI, our other events, our member resources, publications, and more, you can check out our website, ifai.com. And as a reminder to everyone, our 100th annual expo is this November 4th through 6th, 2020 in Indianapolis. So be on the lookout for a registration announcement coming in June. And finally, a very brief 2-question survey will appear when you exit the webinar. We hope you'll take a few moments to complete it, since your feedback helps us provide better quality programming. Thanks again, everyone, and we look forward to hosting you again next week. Have a great afternoon.